Hi everybody! In this video we will consider a method for determining the probability of achieving the target production cost of a product component related to block 3 of our training course. In the video channel overview, the concept of the degree of controllability by production cost of product was mentioned, used by individual authors in works about the controllability of linear and non-linear systems. However, in the course of research, I came to the conclusion that the use of mentioned existing concept is difficult to implement in practice, including due to the need to use mathematical apparatus at the level of not accessible to most potential users. In turn, the concept of probability of achieving the target production cost of component proposed below will be more effective, in my opinion, in particular due to the relative simplicity, due to basing on the classical mathematical formulation of probability. At various stages of the implementation of the product development project, the cost engineers of the project periodically form a list of product components for which there is an excess of the target production cost, for which it's necessary to take measures to reduce it. As a rule, the first approximation of this list has a significant volume, and in the context of the fact that the human resources that can be involved in the formation and implementation of measures are limited, it becomes necessary to exclude from the list of components for which there will be no significant effect for the measures. To filter out the unpromising components from the point of view of reducing cost of components, two methods are used. The first is based on the application of the method of factors research, MFR, that allows preliminary assessment of the financial effect of the events. The second is based on determining the probability of achieving the target production cost of the component, which will be considered in this video. If we continue to develop the idea of using elements of probability theory in the practice of cost engineering, then we can assume that the probability of achieving the target cost of a production can be determined by multiplying the probabilities of achieving the target production cost of its components, i.e. the probability of the product or accomplishment of several independent events of achieving the target cost of production components A, B, C, D. Perhaps a similar approach can be applied for small assembly units. And if we consider machine building products consisting of tens of thousands of components, such an approach is difficult to implement in practice, and therefore this technique is used in the vast majority of cases only for individual components of products. In graphical representation and the presented elementary calculation of the probability of achieving target production cost of the product, in this case, does not carry a semantic load. It's a way for visualization and indicator the importance of controlling the cost of individual components of the product, because reducing the probability of achieving the target cost, at least one of the components significantly reduces the probability of achieving the target production cost of product as a whole. In addition, it's necessary to take into account the limitation of this valuation method due to the fact that product components A, B, C, D should be approximately equal in cost, in production cost. So we come to the first conclusion about the limitation for this method presented on the slide. So, based on the classical definition of the probability of a random event, we formulate the concept of probability of achieving the target production cost of a product. The concept of the probability of achieving the target production cost of a product can be formulated based on the classical definition of probability, where the probability of a random event, C, is the ratio of the number of all possible events T to the number of all possible elementary events N. The compliance of the production cost of the design variant of the product components with the specified target value will be considered a positive outcome, increasing the probability of achieving the target production cost, and the discrepancy will be negative. Let's return to the concept of the probability of achieving the target production cost of a product discussed above. An example of practical application of which clearly demonstrates the difficulties that usually arise when implementing any theoretical concept in practice. Let's consider a practical example from which it can be assumed that when determining T and N, look above, it's possible to the elements of combinatorics. At the level of knowledge of combinatorics corresponding to the school mathematics course, we can propose an engineering technique that can be used, which implies the use of formula of combination, which allows you to choose M from a set of N elements, and the order of combination matters. Example: for the case ABC, the number of all combinations from 3 to 2 is equal to 3 combinations AB, AC, SV. For the case shown on the slide, where A, B and C are not hypothetical elements but components, for each of there are design variants, the situation becomes somewhat more complicated from the point of view of calculation, but solvable. In our case, to determine the probability of achieving the target price, you must first calculate the number of combinations for components corresponding to the target cost, i.e. A1, B1, C1 and C2, then the number of combinations for all components, i.e. A1, A2, A3, B1, B2, B3, C1, C2 and C3, after which you can find their attitude. I think it's clear what the engineering of these calculation methods is. The calculation will involve non-existent combinations, for example, B1, C1, C2, whereas the normal components should consist of combinations of type A, B, C. In any case, even such an engineering technique allows in the first approximation to give the hotheads an idea of the probability of achieving the target cost of the component of the product, and then the products in above case when the product is a conditional assembly unit consisting of 3 components. If one of the listeners has a sufficient level of knowledge in the field of combinatorics and can clarify the engineering methodology given, write in the comments. So, what is the practical significance of the proposed concept of probability of achieving the target production cost of the product? In my opinion, this concept can be used. The first, in the practical activities of machine building enterprises at the early stages of project implementation, i.e. at the stages preceding the decision to transfer the project from the pre-project stage to the stage of more significant investments. The second, accordingly, the methodology can be used as one of the methods for evaluating venture products. Third, this technique can be applied as an alternative method of assessing the degree of novelty of the product for various purposes, ranging from the selection of various design options during design, ending with the risk assessment. By the main method of assessing the degree of novelty, in this case I mean the assessment of the degree of novelty according to the functional model, which will be considered by us in a separate video of Block 1, named of video is the method of a given degree of novelty. The assessment of the degree of novelty by the quantitative ratio of new and old components of the project product. Of course, alpha cannot be discarded as the most commonly used in practice. However, taking into account its disadvantages such as disparity of new and old components in their real value and actual functional value for the consumer, which are often their neglect, and the corresponding error in the calculations, we will consider it as secondary. I suggest we end this for today. Put likes, subscribe, all bye.